Okay, so we're good to go. Okay, well, first and foremost, good afternoon, everyone. Thank you for joining us for our January webinar. This is the webinar is on scalable pub sub messaging with a distributed cache. This is our first time actually doing this webinar. Recently, many of our customers have been bringing up pub sub messaging in their use cases with us, so we figured it was a popular topic and a good topic to cover. My name is Adam. I'm the Regional Director of Service Delivery. So essentially that means I'm the liaison between customers that are evaluating and or implementing NCache into their environment and our internal engineering team. With me is my associate Ron. Ron is our lead solutions architect. When he's not doing webinars such as this one, he's typically working with our customers very closely on evaluations and implementations, and therefore, with that hands-on exposure to our customer base, he's very pivotal in the roadmap and strategy we take with NCache and future releases. So you're in good hands today. During the presentation, if there's any questions whatsoever that you have, you'll notice there's a tab with questions in the webinar pane. Please don't hesitate to ask. We want to make sure everything's all your questions are answered. I mean, that's what we're here for today. So with that, I'll pass it over to Ron and let him get started. Thanks, Ron.
Thank you, Adam. Hi, everybody. My name is Ron, and as Adam suggested, I'll be your resource for this particular webinar. I'll cover different aspects of this feature, the pub sub messaging with the help of distributed caching system. So let's quickly get started with this. In this particular webinar, our agenda is to cover PubSub as a technology. What is PubSub? What are the common use cases? How it is deployed? How you can take benefits out of it, and then we'll talk about some problems associated with PubSub, platforms in general, and then we'll talk about distributed caching as a solution and all the features around it. I have some code examples, and I'll also show you the actual PubSub implementation being tested in our environment. So we have a pretty detailed hands-on portion set up for this webinar as well. So let's quickly get started. First thing that I'll cover is let's talk about PubSub as a technology. What is PubSub? It's a very popular messaging paradigm. The short is PubSub. It's derived from publisher-subscriber model. We have a publisher side of an application or a module within an application, which is broadcasting messages or data independently, and then there are subscribers. That could be another module or a separate application which is receiving the messages out of the platform, and then we have a middle tier, intermediary link between publishers and subscribers. That's your communication bus, a broker. Typically it's a queue which is transferring messages between publishers and subscribers. Now, it's how it is different from messaging queues. It's similar in a lot of ways, but when you specifically talk about PubSub, it's a decoupled or I would say loosely coupled system between your publishers and subscribers. So your publishers does not have to know about subscribers and their topology, and then also they don't have to know about the topology that the messaging communication platform is offering. They can independently publish messages to the intermediate communication platform, and that can in turn transfer it to subscribers. And similarly, subscribers don't need to know of publishers, so they're completely unaware of each other. So that's the beauty of the system, that it's a loosely coupled PubSub publisher subscriber model. Each component can operate independently and normally regardless of other. You can change implementation on publisher and it would not impact the subscriber or the communication channel, and similarly you can change implementation on the communication channel or on the subscriber, and it would not cause any effects on the how publishers work or how subscriber work. So publishers and subscribers send messages, receive messages, and that's a very loosely coupled, very independent, completely unaware of each other. So that's the backbone of our PubSub technology. That's how they normally function. There's a separation of concerns as well. It's not just a queue. There could be multiple channels, we call them topics, that you can use to separate out the messages that you're publishing and subscribing on the application end. So a topic or a channel serves a single purpose. It could be based on the type of the message, for example customer messages, product messages, orders, some backend processing, specific tasks, some scripts that you need to originate, or it could be type based on the load as well. For example, a specific topic can handle say 10,000 messages at runtime, or a publisher can only send 10,000 messages under a peak load. So it could be based on the load that you categorize the messages into load and have different channels for it, or it could be based on the requirements on the application end, that there is a single purpose, a type of message which would dictate that it would go to a specific channel. And on the same lines, publisher connect and publish the message to a channel, to a topic, and subscribers also register interest to the same topic that they're interested in, independent of one another. So middle tier would provide infrastructure for communication. It would allow you to create publish topics, channels for that matter. Publishers get connected to the topic and subscriber register interest to the topic. Publisher publish messages to the topic and subscriber receive messages from the topic, completely independent of one another. And we'll talk about how this is done once we progress into the presentation. This is a typical diagram of a typical PubSub architecture. I've copied it from MSDN. So let's talk about different components. We have a publisher application. We have a communication platform. We have many topics, topic A, topic B, and there could be many more. And then we have subscriber 1, 2, and 3. In this, we have one publisher which is publishing to both topics. So some messages are going to topic 1 and some messages are being published to topic 2. For example, I'll give a very simple example. It could be a customer data which is being sent to topic A. A new customer logs in or gets registered. Publisher wants to do some marketing on that, right? So it can send a message which about the customer, and then subscribers can take that information and do the certain marketing or that campaign that needs to be done. And then there could be order processing within an e-commerce application. An order gets added to the topic B, and then there are subscribers who are dealing with that particular order. So topic A is subscribed by subscriber 1 as well as by subscriber 2. Similarly, topic B is subscribed by subscriber 3 as well as subscriber 2. So publisher is responsible for sending messages of these different topics, and subscriber 1 and 2 are receiving messages from topic A. Subscriber 2 and 3 are receiving messages from topic B. So this is our communication platform. It could be anything. It could be a database, it could be a message bus, it could be a distributed cache. And we'll talk about what are the problems with traditional messaging platforms, and we'll take it from there. But at this point, this is a typical architecture, a deployment setup for publisher application, communication infrastructure, and the subscriber applications. I hope it's pretty straightforward. So moving on, some of the common use cases of PubSub. Any asynchronous data processing or a backend system is a candidate for PubSub. It could be your order processing within an e-commerce, or it could be your customer management within an e-commerce. Any data processing based on some event. If you want to process that data in an async or in some cases in a sync manner, you can use the PubSub. Gaming industry is very popular for it. Chat applications where you have to handle millions of users and their corresponding messages. Financial sector, e-commerce, bookings. Again, they may have to do some back-end orders, booking, batch processing, some calculations, some finance related estimations. So that can be done through a segment with the help of a PubSub, where one application is publishing messages, data consistently to a communication channel, and then that communication channel is in turn transferring it to all the subscribers which are connected to it. And then automation, manufacturing, support systems, any allocation, task allocation, work allocation, or data streaming and processing. These are some of the common use cases of PubSub. It's been in the market for quite some time with lots and lots of active deployments, active use cases around these industry specifics. Okay, so now that we've built some details around what is PubSub, we talked about the definition part, we talked about the architecture and then some use cases. Let's talk about what are the issues with traditional messaging platforms. Now, as you can see that these are independent systems, right? So we could have our many publishers and many subscribers, and these could grow in number. And when they grow in number, they can also have huge amount of messaging load alongside that. So your messaging load can increase over a period of time. If it's a booking system which is dealing with online bookings and then it's processing, there's a component which is processing, and you've utilized PubSub in such a way that there is a load of messages for the current bookings, and then that load is transferred to the communication channel, and then that is in turn transferred to all the subscribers who are actually processing on that data. So based on your number of bookings increase, based on the number of web servers, concurrent users, number of bookings increase, the message load would increase, and would also depend on the number of connected subscribers which are processing that. So that message may have to be relayed to one or all of them, depending upon your application logic. So what happens here is that your messaging load increases as your application load grows. As your messaging load grows, your publisher and subscriber load grows. This load increases, but your PubSub platform becomes a bottleneck. For example, if it's a messaging queue, it has a capacity of say 10,000 requests per second. So that's the bottleneck on that topic or on that channel. It could be database is slow. It's not meant to handle huge transactional load or processing load of huge amount of messages that come and go. And this is a diagram which illustrates this problem, where your publisher and subscriber load increases with the increased number of messages, and then your traditional PubSub platform, a single source usually, and if it's a multiple set of resources, again it's capacitated by the upper capacity that you can handle, say 10,000 requests for a given topic. So this would become a bottleneck. It would show you contention on the publisher end as well as on the subscriber end, and that defeats the whole purpose of PubSub, where these are completely decoupled or loosely coupled system. If it is not able to publish messages, and messages have to wait because this platform is showing contentions, you would see slowness or problems on the publisher because of this platform. And similarly, if you have subscribers and they're trying to get hold of all the messages that they need, but this hits capacity on the resources side, for example the memory runs out or the storage runs out, or it does not have resources, hardware resources to process those messages, this is going to wait because of this. So that defeats the whole purpose of PubSub, where this is supposed to be a decoupled or loosely coupled system where publishers are not impacted by the functionality of the communication channel or the subscribers, and vice versa. But in this case they would be impacted because the underlying communication channel is not able to scale out as your application load grows. So that's the fundamental problem that we're trying to address as part of this webinar, and then I'll show you a solution to this. Any questions so far? So far we've discussed basics of PubSub, architectural breakdown, use cases, and a problem with traditional messaging platform. Any questions so far? So I'll quickly, if there are no questions, so I'll quickly jump to the solution. Solution is very simple. Start using a distributed caching system such as NCache for your PubSub messaging platform. NCache is the main distributed caching product offered by Logisoft. We have a PubSub implementation. It's super fast and it's linearly scalable. How it's super fast? It's in memory, so all the processing of all the messages or data that you've published or subscribed from the communication channel are stored and managed in memory. And nice thing about NCache is that it's not just single source. There could be multiple servers, and you can scale out linearly as part of that. Then we have the diagram which illustrates the the servers which are actually showing the distributed cache cluster. We can see there are many servers instead of one. A traditional platform would just have one source, but in case of NCache, it's a distributed cache cluster. It's Windows-based servers. You can have many servers which can actually be used to start off, and then you can add additional servers on the fly. And then all your publishers and subscribers are connected to this distributed cache tier, and then event-driven messages are published and subscribed based on the mechanism of PubSub. So publishers simply publish messages to in-memory distributed caching system. It's super fast. Multiple servers work in combination to one another, and they transmit the messages to all the connected clients. If it's connected, if there's a topology, there are ways you can relay messages between your publisher and subscribers. It could be published to one of the subscribers, or it could be published to all of them. So it's entirely up to you. But idea that I'm trying to enforce at this point is that this is a very scalable platform. There are many servers that you can start off, and then this grows as your load grows. You can add more and more servers on the fly. So this forms the basis of NCache PubSub system. Preferred platform is 2012, 2016, 64-bit, obviously for more memory reasons. And then only prereq for NCache is .NET 4. Any questions so far? Next, I'll talk about NCache PubSub messaging specifics. I'll show you some interfaces, some code examples, and then some monitoring aspects of NCache PubSub messaging. All right, so next I will show you the same diagram with NCache implementation. So now that we have this initial diagram, we've just redone that for NCache in such a way that NCache is a distributed cache tier in nature. So we have publisher, which is subscribed to a topic, actually publishing to a topic. This is our communication platform, so it's an independent component. We have a publisher component, there is message, and then there is a topic, and then there are subscribers. So these are four components of our PubSub messaging within NCache. So publisher gets connected to a topic. Topic is our own defined terminology for channels or anything which serves a single purpose for a similar type of messages. And topic has all the messages that your publishers publish, and then it gets relayed to all the subscribers which are connected, all or some of them, depending upon the topology. And then similarly, publish 2 is connected to topic 2, and then there are 2 subscribers which are also connected to topic 2. So this is a distributed PubSub dedicated cache tier approach. You have dedicated resources. Publishers could be applications connected to some or all of the topics, and similarly subscribers are the applications which are again connected to some or all of the topics. It's entirely up to you how you design the system and start using it. This is a snippet of
excuse me, just to reinforce the concept, publishers can also be subscribers, correct?
That's absolutely correct, right? So since it's a loosely coupled system, so and you really don't know what publishers are as far as subscribers are concerned, and similarly you don't really know what subscribers are as far as publishers are concerned. So same application can also be publishing data, and if it's connected as a subscriber as well, it can also process that data. Typically a web application, you could have different modules which could be publishing and subscribing. There could be some backend web service which could again be publishing as well as subscribing. So it's entirely up to you how you design the system. This is just a logical breakdown. It doesn't limit you having publishers and subscriber be the same application. It could be the same application doing both tasks. So that's absolutely correct. Alright, so this is a snippet of our publishing mechanism. Typically you have an order object, you get connected to the communication channel, you create a topic, and then you create a message, and then you publish. So this is pretty straightforward. I'll expand on this once you progress. Similarly, we have a subscriber. Again, you need to connect to the communication channel, which is NCache, and then get the topic, subscribe to it, and then there should be a callback of the message. So this is a quick snippet, but there are more examples.
You will plan on showing some more details around the code examples, Ron?
Absolutely. This is exactly what we'll do. We'll have a sample application that I'll showcase, and I'll actually show you all the interfaces such as iTopic, message, and this messaging service. So everything is going to be shown with the help of code examples. All right, so let's get started with this. First of all, we have 4 main interfaces within NCache for our PubSub implementation. So we have topics. We've already defined what is topic. Topic is a channel for communication. It can have a list of subscribers, it could have a list of publishers, and then it relays messages between publishers and subscribers. It really doesn't know about the publishers. It simply gets the message and subscribers. It actually gets the message and relays them to the connected subscribers. Then we have a message interface. It's the object of interest. It could be the object, a serializable payload, because it's being transmitted between 2 different processes, so it needs to be serialized. And then we have the payload, which is actual object of interest, what you're actually intending to send or share between different applications. What data needs to be shared, that's actually encapsulated as part of our message interface. And then we have a publisher interface. It has a bunch of messages, methods, publish messages, receive delivery status notifications. Subscriber is again entity which is connected to a topic, and it actually consumes the data that you send. So publishers publish the data, gets delivery report. subscriber receive the data and then process that. So it's entirely up to you how you define these, but these are the four interfaces that you would be actually using as part of a PubSub interfaces with NCache. So this is a logical breakdown of it. Publisher, we have a publisher, we have a topic, and then we have a message within the topic which stores messages, stores subscriber information, relays these messages to the subscribers, and then subscribers are also connected and they have a message receive notification. Publisher get delivery notifications, and then they transmit the messages. And behind the scene, the communication infrastructure, there could be many topics. This is just one of them. And then these communication topics, channels, they could be spanned over many caching servers. There could be 2, 3, 4 caching servers, and you can add more servers on the fly as well. Alright, so let's get started with our PubSub topic interface. There are 3 main methods which I'll showcase. You could have PubSub topic creation. You can get an existing topic and you can delete the topic. So first of all, although we have the code examples on our PPT as well, but I'll actually take you to the Visual Studio, and here is a sample application which comes installed with NCache as well. I've slightly changed it for my use, but it's pretty standard. It's a console application. It has a publisher project and then it has a subscriber project. So on the topic end, so first of all we have an iTopic class, right? It's an interface. So you have a name of the topic, you have expiration time on the messages that are transmitted to the topic. This could be also on the message level, on the payload level, but there are 2 types of expirations. You could have a message level expiration time, and then you could have a topic level. Message level has a priority, of course, because that's something that you explicitly set. Then we have a callback on topic deletion. If a topic gets deleted and as a subscriber you were connected to it, you want to know about it. Delivery failure notification. If a message fails to deliver, you actually want to get notified. And then there is a create subscription. So on the iTopic interface, these are the members. Create subscription allows you to actually define a callback, get the message as part of that, and then it's a subscriber implementation for that particular topic. Now, what are the methods to interact with the topic? Those are actually exposed as part of our topic interfaces, which are actually exposed by iMessaging service. So these are the 3 methods. It's part of web.caching, and it's iMessaging service. So this allows you all the to expose all the functionality that you need in order to interact with iTopic. So first of all, you have a create topic method. So you can create a new topic with the help of this method, and then you can delete an existing topic. Although there could be multiple publishers connected to the topic, but you have ability to delete a topic. All the messages would be deleted as part of that, but you would get notified if you were not the one who actually deleted it. And then you have a get topic. If you already have the topic and there was a publisher which got disconnected, maybe, right? Although it automatically reconnects to the topic in case of uninformed disconnection, but it could be a topic which you already know exists and you just want to get connected to it. A subscriber would get connected to an already created topic. So let's see the code examples of these one by one. Alright, so first of all we have the create topic. We have cache.messagingservice.create topic. All you need to do is initialize the cache. This is a standard NCache API. You need Malachi salt.ncache.web.caching namespace to expose this. This is our standard connection object. And then you need cache.messagingservice.create topic, and you provide the name of the topic. In this case it's auto topic. So let's have a look at this implementation right here. So within our publisher, we have a start method that's a part of the sample, and all it's doing is connecting to the cache by calling by creating a cache handle right here, and then it's actually connecting to the cache which is already created in this case. So communication channel is something that I'll talk about, how you would create a cache. That's something that I'll showcase once we're done with the code examples. And then you actually call cache.messagingservice.create topic, and this messaging service is the same interface that I've just shown you, right? So it's iMessaging service interface. Actually, it's right here. I'm sorry. There you go. So this is the interface that allows you to call create topic, delete topic, and all the good stuff. So this would create a topic, and as it shows that it returns an I topic, so it actually returned an I topic, which is right here. This is created here. So we have a topic instance, and now we can start publishing messages to this. So let's wait on this. I want to build some more details around the topic interface, and then we'll show you how the messages look like, and then how you actually join these together and actually publish message to the communication channel. Second interface is second method within this is get topic. That's usually done on the subscriber end, or if a publisher which is publishing but it already knows that a topic exists, right? So it would give you an existing topic name from the communication channel, right? So there are three method calls that you need to be aware of. So let's actually take you to one of the subscribers. So within subscriber, you would again create an iTopic. You would create a cache handle, get connected to the cache, launches.ncache.initialize cache, and these are the two libraries that you need at the minimum. You need references to these inside NCache, publisher and subscriber projects, and then you use these to first of all connect to the communication channel, which is NCache PubSub model, and then you have messaging service.get topic. It returns a topic, and then you can actually subscribe to it. And in this sample application, I'm checking if I get the topic. If I don't, I just simply create it, right? So that's the regular implementation where you try to get a topic if you know that it may exist or it does exist, and if it doesn't, you could just go ahead and create a topic of your own. You don't want to create redundant topics, and since it can only have one topic with the name specified, so you need to better check before that. So that completes our get topic, which gets you an instance of already configured, already created topic in the distributed cache PubSub platform. Now, third method within this is the topic interface. The iMessaging service, which exposes the topic functionality, allows you to delete a topic, right? So you can simply go ahead and actually there is a callback, right? And you could actually call delete topic as well. For example, let me just show you this as part of the publisher. Right, so there you go, cache.messaging service. So it's using the same interface, and then it's calling delete topic, the name of the topic, and then on the subscriber end, since it's interested to know about the callbacks as well, so on topic deleted callback is something that you can actually, so that's on topic deleted, which is subscribed by this application right here. I'll show you how the subscription works. So there you go, right? So we have this on topic deleted value, right? So this is a method which is setting up the deletion of the deletion callback for this particular topic. Alright, so having done that, we'll actually cover the callbacks in a bit. So again, coming back to this, we have three main implementations of this topic interface. We can create a topic, we can get connected to an existing topic, and then we can delete a topic.
Just real quick, now that Ron, since you showed some of the code snippets more on the business side, I wanted to add that although we have a really robust commercial or / enterprise version of our caching solution, NCache, this all of the PubSub features that Ron just went over will be available on our next open source release, so available publicly, and that should be within the next week or two. Is that your understanding, Ron?
Yeah, absolutely. So it's going to be made part of our open source. So all the implementation, that's going to be made public. So these interfaces that you're seeing, these are going to be made available. So this messaging interface, subscription interface, all these, the implementation part is actually going to be made available publicly. So it's going to be as part of our open source offering. It's going to be made available, and then it's going to be the open source is also going to be available for that. Thank you for that, Adam.
Thanks, Tom.
Thanks.
Yep, thank you.
All right, so these are the callbacks which I'll cover shortly. Next, I'll talk about our message interface, right? So we've covered topic. There's an iTopic object which has an expiration, which has a name, it has a delivery and deletion callbacks, and then on their iMessaging service, which allows you to create a topic, get a topic, and then delete a topic, and take it from there. So what is the payload? Payload is NCache PubSub message interface, right? So it has these functionalities. So first of all, you could have message invalidation. Like I mentioned, that the invalidation of a payload can be on the topic level. The entire channel can have a expiration value, and then you could have a expiration value to certain messages as part of the support as well. So you can choose both options as well, right? So if a message level expiration is passed as part of the message, so it would have a priority over the topic, the channel level expiration. So if you have, say, topic level expiration of 10 minutes, right, then message level expiration was 5 minutes, so message would actually expire after 5 minutes. And then you have message receive notifications. So subscriber can register for callbacks. They get notified if a message is made available, and then there's a callback method which gets called. So it's an async delivery of the messages. So messages stay in the communication channel. As soon as subscribers are connected to it, they subscribe for a callback method, and then that callback method is called on the subscriber end through an event propagation, and NCache sends messages. Then we have delivery failure notifications, which are registered by publishers. So a message fails to deliver, subscriber becomes unavailable, unresponsive. One or any or all delivery failure notifications can be subscribed to. So it's up to you whether you want one of the subscribers to get a message and you're okay with it, and you get a success around that, or it could be all of them or some of them, because it's a decoupled system. It's a loosely coupled system, so delivery to all the subscribers is not 100% guaranteed, right? So that actually defeats the purpose of PubSub platform. So in this case, it would be as many which are connected, but not always. So there's an automatic retries until the message gets expired. So message would stay in the cache, in the communication channel, in the topic, and if there is a failure, it would just retry until that gets expired, and at that time delivery failure notification is sent. And then we have message encryption and compression features that you can turn on top of it. These are no code change options. So let me just show you these message interface and show you these notification callbacks real quick. So this is our iMessage interface. These are the members. We have a payload, time span, we have an ID of the message, and then this is the default message constructor, and then we have a date time, a creation time. So some members within the iMessage interface. Let me just show this from here. So we have the iMessage interface again, as Adam mentioned, that this is the interface and implementation part of all the messages, the subscription and iMessage service. That's going to be exposed once you have everything publicly available as part of our open source. So this is derived from iMessage interface. It has these attributes: the time span, ID, expiration time, and the creation. Right, and then let's show you how you actually create a message and take it from there. So let's take an order example. We have a payload of named order, right? That's an object. We have all the different values, and then we just create a new message and then set the expiration to that, and then that message is now ready to be sent. So that's as simple as it can get. Let me show you the Visual Studio, my example for it. For example, on the publisher part, I have a message which got created, and then I have a topics.publish message, which I'll show you the there you go. So it takes a message, it takes the delivery, and it has some values that you can actually utilize. So that's pretty much it. And the message, as far as publishing is concerned, delivery option .all or .any dictates that you want that message to be delivered to all the connected clients. Or if you choose any, for example, it allows you to use the any option as well. It would just be removed from the cache as soon as one of the subscriber gets it. It wouldn't wait for the message to be received by all of them, right? So in a task where you want to serve a single purpose by the communication channel, and one of the subscribers need to get the messages, you might want to choose any. Where a message is sent to the communication channel and it's relayed to one of the subscribers, and it's removed from the communication channel. But if you choose all, in that case it would actually be published to all the connected subscribers. It says all, but it's not a guaranteed all, because there could be some of the subscribers which are not active, which are not responsive anymore. They may have a connection active, but it would send it to all the connected clients as per the functionality. But it would not wait and have an acknowledgement for that, because that's not part of the PubSub implementation. So it's again going to be a loosely coupled scenario. So that covers our messaging interface and an example to publish it. On the subscriber end, you need a message received notification. So let's talk about this. So first of all, you create a topic name, cache name, get connected to the cache, get the topic, and then create subscription for it. And inside subscription, you have a message received callback. And on the subscriber end, all you need is a subscriber method, which is right here. So in this particular example right here, I have this message received. Let me go to the program, calling program for it. Alright, so I'm actually calling this subscribe method, and inside this subscribe method, this is based on the sample, by the way. So I have a connection to the cache. I'm actually getting the topic from the cache, and then I'm actually setting a create subscription method for my topic. So iTopic subscription is another interface that I wanted to show you. So it allows you to, there you go. So it allows you to get a topic, and then it allows you to have a callback method for message received, as well as allows you to have an unsubscribe. Implementation of these methods can be made available. This is just an interface, a skeleton for it. So in this message received callback is of interest. So if I quickly show you this method right here, so we have a callback method which gives you the message arguments. Let's see what the arguments are passed to it. So it gives you the message delivery option, and then it gives you the name of the topic, right? So there are some delivery options. You can get a detail around that. You have the message, and then you have the name of the topic. So some specifics around the message and the channel information and the type of delivery that you have. So that's how you would subscribe, and within this subscription method, you can perform your logic. You can just print something, you can process, you can make some database calls, you can update some marketing campaigns, you can process that data and update the customers. So entirely up to you what sort of asynchronous backend processing you can achieve, you want to achieve as part of this support. And then we have, on the same lines, we have autotopic.message delivery failure callback. It's something which is on the publisher end, right? So what you would really need to do is go to the program, and inside the program you would actually you will register for the message delivery failure, and this is the callback method which is going to be called in case a message fails to deliver. So it's pretty straightforward. Publishers get connected to the channel, they create a topic, create a message, publish the message to the topic, and then they were interested in delivery of that message. Similarly, on the subscriber end, you actually get to the topic, get connected to it, and wait for the message to be relayed to you by the communication channel, and then you have all the specifics of the topic, delivery option, and the payload information, and then you can also have a callback method to process that method, and then you can unsubscribe to the it's very simple implementation. But as far as platform is concerned, it's very powerful. It allows you to have multiple servers to host this, and I'll show you the actual hands-on portion by running this sample application. Any questions so far? We've covered all the details around topic interface, message interface, messaging service interface, and iTopic subscription interface. Any questions around this? Next, I'll show you a step-by-step guide on how to publish a message, how to subscribe and receive a message. Any questions so far? For this, what I'll do is I'll go ahead and this is, it would be done as part of our hands-on demo. Let me actually create the environment first and then get started with step-by-step joining all these components together and publishing a message and then receiving that message by another application. So I'll just create a communication channel. In this case, it's going to be NCache distributed caching cluster. Let's name it pub sub cache. It's not case sensitive, so it doesn't matter. I'll just keep everything default. Pick our most popular topology, partition-replica cache. I'll cover this towards the end as well. Async replication, and I just go ahead and create a cache cluster of 2 servers to start off. I can add more servers on the fly at a later point as well. It's a TCP/IP communication. Support is needed. Size is based on the capacity that you need per server. You can increase it, and you can increase the number of servers as well. And then you can set up the auto start so that communication channels, the pub sub cache gets started each time a server gets rebooted. There are multiple servers, so you can restart, add servers, and stop servers on the fly. And each time you restart a server, it should automatically start the cache on that server and join the communication channel, the pool of servers in the distributed cache. So that's pretty much it. That's all what you need. I'll just add my machine as a client. I'm assuming that you already know some basic details about NCache distributed cache cluster, because the focus today is pub sub cache, so I'm not going to do deep details around these features. So this actually creates our cache. I'll start and test it real quick, and then I'll start using the pub sub sample applications. So my communication channel would get started, and after that I'll start publishing data and then start the subscribers as well. And there are some monitoring capabilities within NCache, and there are some specific monitoring capabilities for PubSub as well. Let me just show this as part of this. So our cache looks good, fully connected. Dashboards are not showing any activity at this point, but we can create a PubSub dashboard. And then let's give it 1 column and 1 row. And on the left side we have this topic statistics. That's all what you need. You need the name of the topic. All the topic names would be published, number of messages, number of subscribers, number of publishers, and then there are some other topic count, message store size, message published per second, and then some capacity numbers are also shown right here. These are all pub1 counters. So I think we're good. Let's get started. Let's first test the application with the help of a stress test tool. Let's test the cache with stress test tool, because we need to ensure that we're able to connect to it. There you go. So we have activity on both the caching servers right here. We have activity here as well as here, so we're good. Now we'll actually get started with the official sample. And let me just clear the contents. Alright, so it's all set. Everything looks good. So I'm going to show you the sample application in action in such a way that I'll run the publisher, and the way it is designed is that it gets connected to the communication channel in the start event, then it registers for the failure events, and then it publishes 10 messages on when you press enter. And each time you start a process, it actually picks a name, the process ID gets appended, so you actually know that which publishers are publishing messages. And on the subscribers end, you've simply subscribed to the event in the subscribe method, and then you have also subscribed to on delete event, and then you have a callback method for the message receive as well as for delivery. It's simply printing information in case message gets received. So let's quickly get started and show you some details around it. So first of all, in PubSub we'll initialize, get topic, create subscription, register, actually get connected to the PubSub cache, create a topic, register for some events, create a message, and then publish those messages. So let's get started on this.
All right, I have a quick question, Ron. How do you enable message encryption and compression? You had mentioned it's a node code change, but how do I actually
Yeah,
activate it?
that's a good point. Okay, so yes, real quick, you can actually do this from the cache itself. You can simply enable compression and specify a compression of say 50 kilobytes, and right click and choose hot apply configuration. So that's how your compression would be applied. And on the security side, you need to enable encryption. For that, you need to stop the communication channel, enable encryption, pick your provider, and then apply configuration, then it would be applied. So these are two no code change options. NCache allows you to do this on the messages that are being transmitted between publisher and subscribers. Alright, so bringing it back to the sample application, let's start our publisher first. Let's start this. So the way it is designed is that it actually gets connected to the PubSub cache. And let me just zoom out a little bit. So our process ID 19824, that's the publisher which started, and it actually published 10 messages, 5 without expiry and 5 with 5 minutes of expiry, right? So without expiry means that these messages would stay in the communication channel until you get these delivered, and 5 minutes is these are going to be automatically removed if these are not delivered. Now I need to start a subscriber, and before I actually do that, it's a good starting point where I actually show you some publisher subscriber. So my topic name is my topic. There are 10 messages currently in the communication channel, 0 subscribers and 1 publisher, right? So let's actually add a subscriber by running the subscriber application. And first of all, these 10 messages would be received by the subscriber. There you go. And you can see the 19824, which is part of the message, is actually 19824 is the publisher name. We received 10 messages from it. Now if I bring back the communication channel, we have 0 messages, but we have 1 publisher and 1 subscriber, and that's as per the current implementation. So let's actually hit enter here. 10 more messages are published, and those 10 messages are again received here. Since we would not see this in real time because it's real quick, all you can see is the message count going up and down. So if you have logged these counter, you would better know that when those messages got published and when they went out of the cache. So it can be done in a same manner. Let me just start one more publisher, and obviously it would have a different ID, right? So it again published 10 messages. So on the consumer side, now you have 10 messages, 10 from publisher 1, and then 2384 is another publisher, and you got those messages subscribed and you received the same messages here. On the communication channel, if I simply come right here, we have 0 messages. Now I'm going to close these publishers, these subscribers, and I'm going to publish some messages to show you that you could see a lot of messages. And then I'm actually going to do this for the other one as well, and you would momentarily see that those publisher and subscriber messages, the subscriber is still showing up because I've not disposed it, right? So I've just closed it, but there are 70 messages which are currently available to be published, but there is no subscriber. So let me just start the subscriber one more time and show you that all those 70 messages, based on the expiry of 5 minutes or none, it would actually provide that to the subscriber, which would actually just run, and you would see a mixed process ID. There you go. So these 70 messages are received, a few from 23824 and few from 19824, and these are exactly the process IDs of the publishers, and 19824, and the other one is 23824. So that's how simple it is to publish and start the subscription of these. If I just delete this, I actually get, since I'm using this in a loop, so let me just get rid of it. In this case, it would just publish 10 messages and then wait, and then it would just complete the execution. So let me just start the subscriber as well. So a few messages have been received. There you go. It actually went away because it actually published and deleted. And then we have the messages which were received. And if I come back to the statistics, we now have 3 subscribers and 2 publishers, 0 messages in the cache. So that pretty much covers our step-by-step guide to it. There are command lines, performance counters as well that I can quickly show you. As far as performance support for pub and sub interfaces, where you can have Windows performance counters, which I'm going to show you in a bit. We have topic statistics in NCache monitor, and we have PowerShell commandlets as well. You can run the commands and get the static, the count of subscribers, count of publishers, requests per second, and at real time you can get information through PowerShell commandlets as well. But just to show you real quick, we have this performance counter based monitoring as well. NCache monitoring tool is using the same information, but I wanted to show you this separately as well. If I click on NCache, we have PubSub cache, and if I show you all the counters, there you go. Message store size, count, delivered per second, expired per second, published per second, and then we should have some topic statistics as well. Topics, count, right? So these are some of the values that you can use and log around it. So this pretty much covers our tech details. I'll use 1 to 2 minutes to sum it up, and then I'll hand it over to Adam. Alright, so we've talked about different interfaces. Initially we talked about our platform, what are the problems with traditional PubSub, NCache as a solution, and these are some of the features which would actually help complement on a typical PubSub platform. First of all, distributed cache is highly available. You can add or remove servers, so this complements your PubSub platform. It's a zero downtime, highly available and reliable topology. And in open source you have partition cache, so you have fully partitioning of data. In all other versions, in enterprise we have Partition-replica, so actives and backups are formulated, so it's completely scalable, and at the same time it's very reliable. Many clients are actually using it. Then we actually talked about different interfaces within NCache. Primarily these were 4: topic, iTopic interface, and iMessaging service to expose topic functionality. We have iMessage interface and a message object, which actually allows you to create a payload, set up some expirations, and then we have iMessage subscription interfaces where you can use publish and subscriber methods, and then there are some delivery callbacks and message receive and message topic deletion callbacks that you can use on top of it. So this pretty much covers our PubSub implementation within NCache and some of the architectural benefits that you get in regards to NCache. So this concludes our technical portion. Please let me know if there are any questions. I'll hand it over to Adam for any other question that you guys may have.
Okay, thank you, Ron. Appreciate it. We appreciate it. If there are any additional questions that arise after the webinar, please don't hesitate to let us know about PubSub or otherwise. If you would like a more catered demo of the product to your specific use case, let us know. Or if you would like to simply discuss the technical aspects of your use case and how NCache could help to create a solution, also let us know. We're here to help. We work very closely with our customers during their evaluation, so use us. Again, thank you for your time. We appreciate you joining us this afternoon, and until the next time, be well. Thank you.
Thank you very much, guys.